My name's Amanda Burma. I'm with froglogic, and today we'll be going over automated GUI testing using froglogic Squish, focusing on testing Qt applications. Now, froglogic is headquartered in Hamburg, Germany. We're privately held. We were founded back in 2003, which in terms of automated GUI testing is quite a significant amount of time. We've also had US presence since 2009. Now, we have customers throughout the world. That number is probably a little dated now, the 3,500 customers worldwide. You can recognize some of the logos there. We have customers from all different verticals, different size companies using Squish GUI Tester. So today, as I mentioned, we'll be talking about testing Qt applications, but in Squish, we support a number of different technologies, and when we support each technology, we support it in the same way. So with Squish, Squish itself is cross-platform. It works with multiple technologies, and it's object-based. Now, those are some key items that I'll be covering. You'll hear me refer back to throughout the presentation. So we support testing desktop, mobile, embedded, web, and even hybrid applications. Hybrid applications are applications made up of more than one GUI toolkit or more than one technology. When you're creating tests, our IDE or our test creation application is cross-platform. So whether you're working from Linux, Mac, or Windows, our IDE works across all of those platforms. That's not something you're going to see with a lot of tools out there. When you create tests, you have the ability to create tests in a business-readable format using Gherkin. Gherkin is a BDD standard for creating and defining features and their scenarios. So think about that as defining how a feature should work and use cases, if you will, for how that should work. Now, when you automate your tests, you have the ability to record or script or either. So it's an and/or. And when you do so, you get to choose between using Python, JavaScript, Perl, Tcl, or Ruby as your scripting languages. Now, many people often ask, which scripting language is the best for Squish? And then I turn around and ask, which scripting language is the best for your team? Because no matter which scripting language you use, you're going to have the same Squish functionality. So we allow you to be able to choose from different scripting languages, and that's based on what's the best fit for your team. Now, all of those scripting languages they're interpreted because they're scripting languages. They're cross-platform. So that gives a nice flexible architecture for distributing these tests. You don't have to compile to distribute as you do with many other automated testing tools out there. Now, talking about distributing your tests, we offer a complete set of command line tools as well as a number of different integrations into CI and ALM tools. And that's going to allow you to tie Squish into your processes. Now with our results, when you run your tests from the IDE, you're going to see your results right there, but that's when you're creating these tests. When you are running these unmanned, so after you've created some tests and you're going to run these, let's say as a nightly batch process or as part of your build process, we offer a number of different output formats for your reports, different versions of XML, spreadsheets, text files, HTML, HTML being our most common. And that's what appears in many of the different integrations. Now that's going to provide you not only your pass-fail information, screenshots if you'd like to capture those, any logging information you choose to include, but it will also include execution statistics and drill down details about the various steps in your results. Now with Squish, when we support a technology, we have dedicated support then for that GUI toolkit. Now this is again something that you're going to find different between us and some other tools out there. When we support a technology, for example, we're talking about Qt today, we support that technology across the platforms on which it's supported. So if you're talking desktop Qt, well, that's across Mac, Windows, Linux, right? You can create your tests on any of those platforms. You can execute them. You can create it across any combination. Many tools out there may have their IDE limited to Windows or execution, or if they allow it to be cross-platform, They're not working with an object-based approach, they're working with an image-based approach, which we'll talk about a little bit later. So all of these GUI toolkits you see listed on the left here, the same applies. We support them on the platforms on which they are supported. Now I mentioned this object-based thing a few times. If you're not familiar with automated testing, that might not mean a lot to you. If you are, you've probably heard object-based versus image-based, using object properties versus using XPath, things like that. Well, in Squish, what we do is we identify objects based on the characteristics of those objects. So in Qt, you have your widgets, you have the properties of those widgets, and then the values. Now there's a certain set of those properties that make that object unique in any given circumstance or in specific circumstances, and that is how we identify objects. Now what that means is not only can we find that object, we can find that object if it moves around. If that object changes, we can handle dynamic objects using pattern matching, regular expressions, or wildcards. And because those objects with Qt are the same no matter what operating system you're on, we can execute those same tests without modification across the different platforms. Now we also support complex and custom controls and give you access in your script to your application's API. So in Qt you have your Qt API, your C++ API, and we'll talk a little bit more about that on the next slide here. We also, which is something quite unusual for a commercial tool, share our source code with customers. Now, while we're not talking about touch applications today, you could be using a Qt Quick application, for example, or a Qt for embedded application. And for those and any other touch applications that we support, we have a gesture editor where you can record, modify, and call gestures, much like you would a function call. And we also support single and multi-touch gestures. Now I mentioned I'd talk a little bit more about our Qt support. Our founders come from the Trolltech days. They were developers for Trolltech, so working on the Qt product. They know more about Qt than probably most. And as far as automated testing tools go, well, our support for Qt is unsurpassed by any other tool out there given our knowledge of the Qt platform. Now, as I mentioned before, we support Qt and any of the technologies that we support across the platforms on which it's supported. Those scripts work without modification across those different platforms, and we support up to the latest and many prior versions of the Qt toolkit. Now you get access from your scripts to a number of different components of this Qt toolkit. So to the API, to your signals and slots. There's more information on our website about this. I don't want to bore you and read this whole slide about the extensive support that we have for Qt widgets. Now let's talk about how we're going to create tests. Squish has built-in BDD support, behavior-driven development and testing, if you will, support. BDD is a standard, Gherkin being the standard language for defining a BDD test. Those BDD tests are called feature files. In every feature file, you have a certain number of scenarios which describe how that feature should work using how an end user would interact with it. Now, anyone can write this, anyone can read this. That opens up who can create these tests to a wider audience. Now, what we've done with Squish is we've allowed you to write these tests, but also then help you record these tests, so help you automate them. We'll walk you through how to record these tests. We then display the results directly within that feature file, and your results are automatically easier to read because they're using that same format. It makes it easier to troubleshoot your tests. It makes it easier to identify where an issue may exist and pinpoint that area. And it also makes your results much more readable to anyone. Now, as Gherkin is a standard, any tests you've written in any other tool, or maybe you've written them in Notepad, are 100% compatible with Squish. You can take that and you can copy and paste that feature file into Squish. You don't need any other tool to make the BDD support work. Now, underneath this feature file, almost think of it almost as a layer, is the automation, is that test script or scripts. They're automatically modularized for reuse, and we will see that today. Now, before we get to the actual demo, I've got a few more slides here. I think about 3. So imagine, if you will, that you're on your desktop and you've clicked record within your application or within the Squish IDE. Now, when you click record behind the scenes, what Squish is doing is the Squish runner is connecting over the network using TCP/IP, so this could be local within the same machine or connecting to a remote machine, to a listening Squish server service. Now, when you're working locally from the IDE, that Squish server service is automatically triggered. When you're working on a remote machine, you just have it sitting there listening. And with this service listening, the Squish server, what it's doing is it's launching your application, injecting the Squish hook, and that's what's allowing Squish to monitor those actions that you're performing in your application. So it then reports those actions back to the Squish runner, which generates your test scripts. Now, those test scripts, again, can be recorded in Python, JavaScript, Perl, Tcl, or Ruby. Now, does that mean you have to record everything? No. You can record, you can script, you can take any combination thereof. So that's recording. Now, when you're executing, it's very similar, except this becomes a one-to-many relationship. So again, imagine you're sitting in your IDE and you click run on one of your tests or a whole set of your tests. It takes those test scripts, the Squish runner then connects again over the network, and this becomes a one-to-many relationship. So what you have is the various listening Squish server services. Again, this could be one local, or it could be a number distributed across your network. It will then launch the application, injecting the hook, and this time, instead of listening to what you're doing, recording those actions, this time it's going to perform those actions. It's going to execute the test and report back the success or failure and any other logging information that you'd like of those actions, and then generate those reports. Now, this can be done using your IDE by simply clicking run. This could be done using our command line interface. This could be done using one of our many different integrations. Now, let's take a look at, for example, Qt for Embedded. And this just illustrates that no matter which toolkit or technology we're working with, Squish is going to take the same approach. We're recording, we're executing. So it all has the same approach no matter which toolkit we're working with. Now, I've mentioned a few times that you have a complete command line interface and that you also have a number of different build tools or a number of different integrations, including build, ALM, and CI tools, which can help you tie Squish together, whether you're using them to put Squish as part of a build process and execute those tests, or maybe you are logging defects, maybe you're tasking individuals to review the results or execute these tests. As each tool that we integrate with is slightly different or very different, our integrations are going to then be different to meet the needs of that tool and how Squish best works with those tools. Today, time permitting, we will see an example of the Jenkins integration and triggering tests across different platforms, including cross-platform testing execution. So the first thing that I'm going to do here is I'm going to open up my Squish IDE. Now, for those of you that have worked with Eclipse before, this IDE may look familiar to you. Our IDE is based on Eclipse. Helps it be cross-platform too. You can use Eclipse and use our add-in instead of using the IDE we ship with. You'll have the same Squish functionality. Now what we have right here is I have a test suite with a number of different test cases, and I can execute those, I can manage them, but what we're going to do first is create a new test. And I'm going to create a new BDD test case. Now when I create a new BDD test case, I automatically am given a nice little template here. Now let's say you already have a BDD test or you're so familiar with the Gherkin language that you don't want any of this in there. Sure, you can just delete it. I kind of use it as a guide when I'm writing my new tests. I can describe the feature that I want to test. We'll call this filling an address book. I can add some descriptive information. This all helps. It becomes almost your documentation. It's describing the feature as it should be developed and as the test should be executed, as it should be documented, as end users should understand how it works. Applies to everyone. So then each feature file can have a number of scenarios. We're going to create one with just one simple scenario. All right, so there's some keywords in the Gherkin language if you're not familiar with it, and there's documentation out there on it as well, but we're going to go with something really basic. Given, and we'll say, given the application. Now, one of the things you'll notice is as I start typing, you'll notice another window comes up. So much like code completion, we have what we call statement completion. And this allows me to automatically see and reuse components that I've automated previously in other test cases. So I can reuse that by simply selecting it. Now, one of the things you'll notice is that warning statement goes away. These other lines have warning statements, this one doesn't, simply indicating that there is an automation component behind it. It has been automated, whereas these statements have not. No implementation found for step and another precondition. So those are things that we then need to automate. Well, we want to use what we want to automate, not the base template. So when a new address book, and you can see I've done this a few times so I could reuse them, but I want to show you how to create and record them. So I'm going to use different wording. When a new address book is created, then zero entries should exist. So you create a new address book, it should be blank, right? And I'm going to get rid of the other lines here. Okay, so I have my first feature file with one scenario. You can have many scenarios, again, as I mentioned. So how do I automate this? You know, if I click run right now, there's nothing behind it other than that first step, right? So what I want to do is I want to click record. Now, I only have one scenario, so I'll click record up here. Should I have multiple scenarios, each scenario will be listed, and I can record or execute each scenario individually or the entire from up here. So I'll click record. Now what that is going to do is that's going to launch this nice control bar, which is walking me through how to record this test. So remember, given the application's running, I reused something that was already automated. So it already went through that step and completed that one successfully. And now right here, it's prompting me to record this step when a new address book is created. So I'll come to my application, I'll perform that action, and I'll let Squish know that I'm now done with that step. Goes on to the next step, then zero entries should exist. Well, you know, I can see the fact that zero entries exist right here, right? But how can I verify that? Well, in Squish, what we have are called verification points, and that allows you to verify an object and its properties, which is the most common verification point. We also support verifying screenshots. Now, think about it this way. Data versus images. Data is going to be more reliable, easier to verify, more comparable, right, than images. But we do support screenshot verification points. With your screenshot verification points, we allow you to set a threshold for a margin of error. We also allow you to add positive and negative masks, being able to focus on a certain area or black out a certain area to not include in the comparison. So that's available to you, but keep in mind resolutions, operating systems, anything like that can really impact those. So most people stick with the object property verification points, but the others support it as well. We also have table verification points that allow you to verify a table and its values. So we'll go with the object property verification point. Now what that will do is return me to Squish, where I can come use my pick tool. Now I have my entire application object tree in the same window there. However, I personally like to make things easier on myself, not navigating a tree if I don't know where something is. So I can use my pick tool to come in and hover over the various objects in my application. Now when I do that, I'm going to see some context-sensitive information about that object, about these various objects. And I can select the object I'm interested in verifying. Now when I do that, you'll now notice my application object tree is narrowed down to that particular widget. And I can also see all the properties for those widgets. So for example, I can see that the row count is equal to 0. Well, I wanted to verify there weren't any entries in my address book when I created a new address book, and a row count of 0 in this particular application is indicating that to me. So I'm simply going to click Save and Insert. Now I could verify multiple objects here, I could verify multiple properties, all of that. I'm going to keep it simple on this first one. Okay, so I'm done with that step. Well, that was the end of my scenario, so not only am I done with that step, I'm also done with my scenario. Now you'll notice all the warning lines have gone away because I have now automated it. And we can also see that we successfully went through and recorded everything. And this is what your results will look like as well. Very easy to read, very easy to understand. So how do I execute this? Now if we're working from the IDE, I simply come here and I click Run. Unmanned, we'll see that a little bit later with our command line interface or an integration. So I'll click Run, and it will execute that test. So it's going to go through the application's launched, when a new address book is created, then 0 entries should exist. Now, for some reason, it is pausing here. Isn't that great? Okay, let's try that again. I'm not sure what's going on here. One of the great things with demoing live is that if we encounter an issue, well, you get to see me troubleshoot it live. All right, so that executed really fast. There's ways I can slow that down if you'd like, which I do sometimes from webinars and demos, but fast is good when you're executing these unmanned. Now you'll notice when it executed, we have their color coding directly within the feature file. I can see that it passed. I can also see my test results down below. Any test result step I click on, it will show me the corresponding line in my test. Now, these words alone, these statements, don't automate the test. There's no magic, and if anyone tries to tell you that there's this magic in automated testing and that you can record everything and that's all you need, you might want to read more about automated testing because you're going to find out that's not the case. So what we have here is we have these different statements. So if I right-click on any of these statements and select Switch between feature and implementation file, I can then see how this is automated. Now what this did is this opened up my steps. In this case, I'm happen to be using Python as my scripting language. Remember, you can use JavaScript, Python, Perl, Tcl, or Ruby. And that happens to be a test suite resource step file. I can have as many step files as I want. And any of these step files, any calls within them, any of these functions defined here, are automatically available to any test case in my entire test suite. So when I'm recording these BDD tests, Squish is automatically modularizing the test for reuse as it's dividing each by its statement and then the actions within that statement. So in this case, a new address book is created, has activate item, this Q menu bar, clicking file, activate item, Q menu, or file, Q menu, clicking new. So that's the steps for the when a new address book is created. Now, for each of these areas that I recorded, I have, you'll notice these wait for object item and wait for object statements. Now what those do is those make sure that the object is in a state ready for an end user to interact with it before it executes that statement. So what it does is it makes sure the object exists, that it's visible, and that it's enabled. If you think about it, you can always make an API call to trigger an action in your application, but that doesn't mean an end user can perform that action. The item does have to be visible, and it has to be enabled, right, in order for an end user to interact with it. So it's waiting for that. Now what it's doing is it has a 20,000 millisecond timeout as an optional parameter. Now what that means is that you've got 20 seconds from the time it reaches that step for that object to reach the visible and enabled state. Should it not, Squish will, from the IDE, prompt you to resolve the issue why it can't find the object. And if you're running it unmanned or not from the IDE, then it will indicate a failure and that it can't find the object. Now you can log other information with it as well. Now, how is it finding these objects? So what you see in your script when you record are these symbolic names. A symbolic name refers to an entry in your object map. So if you right-click on any symbolic name in your script and select Open Symbolic Name, what you'll see is an entry in your object map. Now, the entry in your object map is then automatically highlighted, and you can see how we're finding that object. So the symbolic name followed by the real name, the collection of properties that make that object unique. Now, here we have all these constants, right? Let's go take a look at another example object. For example, this main window here. Anytime I have a main window in this application and I open up an address book with a different name, that window title changes. Well, I know it's the same object. However, there's a component that changes and there's a component that remains the same. Now, if there's a component that changes and a component that remains the same, instead of using a constant, I can pattern match. I can use a wildcard or regular expression. A wildcard being a very simplified form of a regular expression. An asterisk, anything after this, I don't care what happens or before. So we can see here it's address book, space, dash, space, and I don't care what comes after it. Whereas when it was first recorded, it was address book, space, dash, space, the name of the address book I had open. So I can pattern match to handle dynamic objects. Now there's a lot of other features in the object map that we won't have time to get to today. So this, as well as other features that I'll point out, are also covered in short video tutorials in our video library. So I do encourage you after this webinar or when you have some time within, a short period of time after the webinar, to view some of those video tutorials to help supplement the information that you've learned in the webinar. So that's how we're finding those objects. Now, all I've done is recording and playback, and by no means is automated testing all recording and playback. And anyone that tells you it is, again, read more about success and failure implementations of automated testing. Just a nice Google reference to it. So what you can do is you can manually script as well. So you have the ability to manually script anything, to set breakpoints, to run to a breakpoint, to record what are called snippets, so just recording a few steps at a time. Anything legal in the scripting language that you've chosen to use is legal in your tests. So if we take a look at the tutorial that we ship with, you can see there's a number of different scenarios, and they're not just given, when, then. There's other things you can do. You can have variables, you can have data tables, you can data drive it from the BDD level, from the feature file level, or you can data drive it at the script level. Anything I happen to be using Python here, so anything in Python I can call and I can use in my tests. It doesn't have to be just recorded or scripted here. I can have shared script files. For example, I have these shared functions over here, and I can call those shared functions. Now, one of the things you'll notice in one of these, invoke a menu item. So in this particular application, I have different menu combinations: file, new, edit, add, etc. I don't want to have lines for those every time I need to use them. It's almost a waste, right? You can make this more efficient, and that's one of the things. You want to modularize and make things more efficient by refactoring your tests or enhancing them. So what I have here is I have a function that allows me to call any menu combination in my application by simply passing in the menu and the item. Now you'll notice something different from here than my symbolic name. What I'm doing here is I'm using a real name, so I can dynamically build the reference to that object at runtime. So I'm actually using the properties indicated in the object map and then passing components in as variables. Now, there's a time and a place for both. The reason to use a symbolic name most of the time is that you then have one single central management point for managing object references. An object changes in your application, you don't have to go find every instance where it's used. You go to that one central location, the object map, make the update there, and all tests don't need to be touched. However, in cases where you don't know how to find that object until something happens a step or a few steps prior, that's where you can use a real name from within your test case. You can also dynamically build the reference to symbolic names at runtime because it's just building that string. So let's do this. We're going to go to our tutorial, and I'm simply going to set a breakpoint, and I'm going to run this scenario. So the forename and surname is added to a table. Now when I reach my breakpoint, I have access to the variables to view the variables and their current values in my test. Now I'm still at the BDD level, so let's use our debugger to step into the script here. So I can see any variables and their values in my test script. I can step into, I can step over any of these actions, and what it will do is then perform the action in the application. Now from here, I also have the ability to record a snippet. Maybe I forgot some steps, or I'm recording in snippets, meaning small bits at a time. I also have access to my script console. Now again, I'm going to mention that there's more about the Squish debugger, there's more about the script console to learn about than what we have time to cover today. So where are they? Small under 5-minute video tutorials in our video library on our website. Don't forget to download the slide deck that's included as a handout in this webinar, as it gives you links directly to that. You can also just go to froglogic.com resources and you'll see a link to our video library. So I can step through this, I can see all of the information regarding it, I can troubleshoot whatever I need to do. Now let's say that we get to a point in our test, and I'm going to go to a different test here, and we can't find an object. So let me find one that is clicking on the OK button. Okay, so we have this object here. What I'm going to do is break my script. Open the symbolic name. Here I can see it. And instead of OK, I'm just going to put yes in here. So it's not going to be able to find this object, right? Well, how does Squish react when it can't find that object? When I add new persons to the address book. So let's go find, we're going to run this scenario. State after adding 2 entries. So it's trying to find that OK button. Now remember, when it tries to find an object, it makes sure it's visible and it makes sure it's enabled. But it also waits 20,000 milliseconds or 20 seconds. No end user is going to sit around for that long, but there are ways to extend it or add more troubleshooting around that. So add more logic around it to wait, try again, or however you'd like to handle that. We do have exception handling and error handling available. So what it does is, if I'm working from the IDE, it shows the error that would have appeared in the results had I been running this unmanned or suppressing this feature. It shows me what it's trying to find and gives me the option to go out and pick an object. So I'm going to select that object. Now what I'm able to do is see the difference between the existing entry in the object map and how the object exists in my application today. If I click retry and it works, it will automatically update the entry in my object map. If it doesn't work, it returns me back to this window. I can throw an error, I can debug, however I'd like to proceed. It worked, it continued, and now if we go look at that entry in our object map, we'll see that it has been updated. So there's a number of different neat features. Again, don't have time to cover them all today, but that you have the ability to use. For example, global scripts as well, which are scripts external to your test suite, but in the same scripting language, simply referencing a folder. You can ignore this one, where I have some different scripts that I can call from any test suite. So what I'm going to do now is show you how I can run some of this unmanned. So what I have is, first of all, I have a Jenkins server running. And then I have, you can see here, a virtual machine where I'm running Qt52. I'm running Squish. It's listening on this IP address and port, so the Squish server services. So what I can do is I can trigger tests from Jenkins, from my command line interface. I can trigger them to execute across different machines. And if I were to open up the IDE on this platform, it would look just the same. It operates just the same, all of that. So what I'm going to do first is I'm going to have a Squish server service listening on this machine as well. Now, one of the things you'll notice is there's a lot of other things in here other than just calling the Squish server service. Enhancements I like to make. I like to print out, for example, and this is a batch file. You can do this in a shell or bash script as well. But I like to have some information print out to confirm, because I work across so many different platforms, operating systems, and Squish editions, working with different technologies. So I'm simply going to call the Squish server service and have that listening here as well. I also implemented a minimize, so it automatically minimizes it. So I have that as well. And now what I'll do, I'm going to run this here, and I'm going to have this. So I'll come here and I'm going to execute against my Linux box. I'm going to do a build. So what I can have with Jenkins is I can have build steps, which as a build step I can have Squish execute tests. So I'm going to run it from here, and I'll run from here. And what that's going to do is execute tests. You can see one's now running across the Linux box, the other is running natively on this Windows box. So you can imagine you could distribute this. It's the same test. It's a different operating system. I happen to be running that tutorial, so it's running a number of different scenarios back to back. And then I'm able to see my results directly from Jenkins, which will show us a nice example of HTML results. And with that, I'm going to open it up for questions at this time. We have about 20 minutes remaining where you can begin asking questions, and I will show you the results. So everything executed, I can see here that it executed. I can see my entire build results, but I can also see my Squish report as part of my build results. So I can see one test case executed. I have this nice summary result information. I can expand this, and you'll notice our results are very easy to read. You have your feature, the scenario that executed. I can zoom into any different level and drill down to those details and see additional information. I can capture screenshots in here, any logging information I'd like, but the results are very nice and easy to read and have execution statistics as well as information that I can drill down into. I can also move back up the chain here. This summarizes some of the information that we've covered today, again available for download in the handout, going over the cross-platform nature, multi-technology, object level support, our IDE, how you can record and script, as well as use the built-in BDD framework. Now you can download an evaluation at froglogic.com evaluate, and we also have a number of different resources at froglogic.com resources, including our documentation, our knowledge base, access to support. We also publish Squish Tips of the Week and have our video library. So some examples that would be good to look at following this webinar. Those are some sample topics, as well as links to either our YouTube channel or the video library from within our website. Again, these are clickable URLs so that when you download the handout, you will have access to those URLs.